Today we are going to discuss the time value of money. Although some students are intimidated by calculating the time value of money, it's important to understand how significant this concept is. The time value of money affects every financial decision you make, whether it's an investment, a credit card, a car loan, a home loan, even money sitting under your mattress. The future value of money deserves your understanding. I'd like you to have some paper, a pencil, and a calculator handy before continuing this lecture. Please put me on pause and resume playing once you have these items. Okay, let's make sure we're on the same page with these definitions first. Present value is the amount of money you have right now. Future value is the amount of money you have right now after it grows when compounded at a given rate. So here's an example. Let's say you received $100 for your birthday from your grandmother. Being the wise person you are, you decide to deposit it in the bank at 10% interest. You leave it in the bank for 2 years. Obviously, 10% interest is nowhere near realistic, but it will help make the numbers clean and neat for this example. In this example, our present value is going to be $100, our interest 10%, and our duration 2 years. So what's the future value of this deposit? Take a few minutes to pause this video and consider what you think the answer is. Your answer should have been $121. The future value of this deposit is $121. The first year, your deposit would have earned 10% interest, so it would have earned $10. You would then have $110. The second year, your $110 would earn $11 in interest. You now have a total earned interest of $21. Therefore, at the end of the second year, the value of your deposit would be $121. How did your answer compare? If your answer was $120, then you forgot the very important tool of compound interest. Every period, whether it's yearly, monthly, or daily, your interest compounds. Your present value of money has the potential to grow quite quickly. In our birthday money example, it's easy to calculate year 1 and year 2 separately and then add them together to calculate our future value. But what if our interest was compounded monthly for 2 years? Well, again, we're not going to find a bank that will offer 10% interest compounded monthly for 2 years, but just play along. We would need this equation here. Future value equals present value times 1 plus I to the power of n. So we know future value is expressed as FV, present value is PV. I is our interest rate per period, and n is the number of compounding periods. So in our example, our present value is going to be $100, our interest is 10%, and we are looking at 2 years with monthly compounding interest. So n would be 24 periods. 2 years of 12 periods, 12 months each, would be 24 months, 24 periods. Say we were looking at 3 years of monthly compounded interest, n would be 36. Maybe we were compounding daily for a month, we would use 30 for n. But again, in this example, we're compounding monthly for 2 years, which is 24 months, so n is equal to 24. Now, something we do want to keep in mind when we're using this equation is that the periods for I and n really need to be the same. So if we're talking about annual interest of an investment, then the number of compounding periods must be expressed annually. If we're talking about daily interest, then the number of compounding periods must be expressed daily. So 1 year would be expressed as 365. You've probably noticed this on credit card statements, as the interest is usually calculated annually at maybe 13%, but you're usually paying interest on an amount that's calculated daily. So back to our sample problem, $100 compounded for 24 periods at 10% interest. What will our future value be in 2 years? Well, our equation is going to look like this. Future value equals 100 times 1 plus 0.10 to the power of 24. So that's 100 times 9.85 So our future value is $984.97. Wouldn't that be nice? $984 with just a $100 investment. Not realistic, but we can still have fun with the numbers. Now let's pick a more practical example. Say you want to buy a house for $180,000. If the real estate in our area is expected to increase by 2% each year, what will be the value of our house in 7 years? Please place this lecture on pause and calculate the answer. The answer is $206,820. Our house would increase in value by $26,820 over a period of 7 years. How does this compare with your answer? This is how I worked the problem. Future value is equal to 180,000 times 1 plus 0.02. We get 0.02 because it's 2%, expressed as a decimal would be 0.02, to the power of 7, 7 being the number of years. So 180,000 times 1.149 is 206,820. Now your answer may have varied a little bit. If your calculator only calculated to 2 decimal points, for example, you would have multiplied 180,000 times 1.15 and received a future value of 207,000. This equation, like all other equations, can be worked in reverse. So let's say, for example, I will pay you $1,000 in 5 years. How much money are you going to give me now to make it fair to me? We're going to use 6% interest in this example. So to restate, I'm going to give you $1,000 in 5 years' time. How much are you going to give me now to make it fair to both of us? So this is what we would look like. $1,000 becomes our future value. Now we're trying to solve for PV, our present value. You can see 1 plus 0.06, that's because we're assuming 6% interest in this example, and N is 5 for 5 years. So 1.06 to the power of 5 is 1.338. We're going to isolate PV, so it's going to be 1,000 divided by 1.338, which is $747.38. So what this means is that you would give me $747.38 today, and I would return $1,000 to you in 5 years. So if you want to look at it from another way, you can say, I'm going to invest $747 now at 6% interest, and in 5 years it would be worth $1,000. This is much like a bond. I hope this helps explain present value and future value a little bit to you. Please don't hesitate to ask if you have any questions.